Hello, boys and girls. Welcome to Mrs. Bandu's Math Movies. This is Lesson 8.8 for Course 2, Three-Dimensional Figures. So we're going to classify and draw three-dimensional figures. As you might be thinking to yourself, this has got a ton of definitions. So let's get right into them, and here we go. A three-dimensional figure, or solid, is a figure that does not lie in a plane. In other words, it's not flat. Okay, it's three-dimensional. Okay, a face is a flat surface of a solid shaped like a pentagon. A polygon, excuse me. Okay, so a face is the flat surface of a solid shaped like a polygon. Okay. An edge is a segment formed by the intersection of two faces. Okay, so let's scoot over here for just a moment. This is the face right here, and it's actually made up of many faces. So let's put our label for face in here. And then this segment right here would be an edge. Oh, well, it is an edge, but that's actually going to have a better definition. Let's go with edge up here because I see a better definition for the one I had filled in first. So the edge, any one of these is an edge. So you have multiple edges as well. Okay. A prism is a three-dimensional, and I'm going to abbreviate three-dimensional as 3D, figure with two parallel and congruent polygonal faces, which are known as the bases. So I'm going to go over here, and this is a base, and this points to a base as well. The bases of a prism are parallel and congruent polygonal faces. Okay, if you look here, this is a hexagon. So this, what we have here, is a hexagonal prism. The word I scratched out a moment ago was actually height. I should have filled in with the word height. And the height of a prism is the length of a perpendicular segment that joins the bases. Okay, and again, they didn't leave room to write this, but when we name a prism, it's described by the shape of its bases. So again, we have a hexagonal prism that we have given to us right here. All right, a cube is a rectangular prism with faces that are all squares. So a cube. Probably the most common cube is a die that you roll. Okay, a cylinder two congruent parallel bases that are circles. And here are our bases in this picture. And this is going to be the height. Now in all of these we're defining height because when you're trying to figure out surface area and volume, we're going to need that dimension. That's why we're pointing that out on all of them. The height of a cylinder is the length of a perpendicular segment that joins the bases. Alrighty, let's move on to our next one. And we have, this is a pyramid. A pyramid has triangular faces that meet at one point, a vertex, and a base that is a polygon. Okay, so here's the base, the bottom basically, and the vertex. Okay, this looks like it's a rectangle, so this would be a rectangular pyramid. You could have a triangular pyramid, a hexagonal pyramid, etc. So again, pyramids are named by the type of base they have, and the base is always opposite the vertex, and the word pyramid. So they're named in a similar fashion as prisms. Okay, a cone has one circular base and one vertex. So our vertex and then our circular base. And our final term is sphere, S-P-H-E-R-E. A sphere is a set of all points in space that are the same distance from a center point. And the sphere is generally named by its center point if it needs to be named. Okay. And then, not sure why they did this, but they have, as an example, name the geometric figure and they give you a sphere. Okay, like the easiest thing. But anyway, we will be looking at others as well, so rest assured there's going to be more for you to do there. Okay. Here is just a little practice in drawing a three-dimensional figure. So we want to draw a pentagonal prism. So the first step is to draw a pentagon. Okay, so after you finish that step, it should look like that. Second step is to draw a second pentagon congruent to the first. Okay, my recommendation is it might be easiest to draw under rather than trying to scoot it off to the side, but it doesn't really matter. I'm just going to draw right under, and I'm going to put in the points because I can reference the points and then I can connect them. Okay. Whoops, and I went to the wrong place on that one. Should have gone there. Okay. And then we want to connect the vertices, so you can decide at where you're going to be looking at this. See, I really should have dashed that one probably, because that's going to actually be hidden. Okay, so on these I should have dashed this line right here. So I'm going to go back and do that. My apologies on that. Connect the vertices, use dashed lines for the hidden edges. Okay, so from this perspective I intend for this to not be seen because you're looking at it from the front. Okay, so I should have dashed it and I didn't. So that's why I have those little hash marks on it. Okay. All right. You have a couple more to name. and then use the grid to draw a triangular prism. So you're going to go and do your own. And in number 3, I'm just going to leave, I'm not going to repeat that up there. Okay. All right, so review these definitions, please, and we will be ready to work with this in class.